Hello, and welcome to Secure Smart Home Protection. My name is Joel Cologne, and I'm working with Alan Severino and Patrick Dinner on this project. So let's get right to it. For this portion of the demonstration, I'll be reviewing the two-factor authentication web application. So here I've already started it up. We have a simple kind of Amazon login kind of screen. So this screen would basically show up on the Echo device, or like the Echo Show when they're trying to purchase an item, and it would just kind of prompt them for their Amazon email and password. So just to make sure that you know they they have the first valid credentials to make a purchase. So for the purposes of the demo, I just created some dummy variables um, for testing out this. So I coded it in to have the username as test and password as password. So we'll just input those in, but ideally it would have their Amazon email and password. And then it brings us to the second screen, which is the actual two-factor authentication, which basically acts as a sort of kind of second pass blocker between the user and purchasing something on Amazon. So this is a simple screen. It just generates a secret key, which you can then input into the Google Authenticator app. And the Google Authenticator app will spit out a one-time password, which can be inputted here to make sure that it's clearly you. So ideally, this would be done on a different device. So you would have access to your phone or your iPad. So you would be kind of like authenticating with two devices. But for this purpose of the demo, we're going to use the authenticator um, that I've downloaded on my desktop, which is also using Google Authenticator. But here we can add an account and we can copy the secret token. Um, Oops, where did, let me just. Okay, so we can copy the token, uh, and basically this will just generate a one-time password. So here we have 328-897. Just authenticate that. And we have the 2FA token is valid. And then if we enter, an invalid token that isn't generated from Amazon, from the Google Authenticator app, it will give us a invalid 2FA token. So ideally, you would be doing this from a different device, so that way it would be more secure, not from the same device. But yeah, um, thank you so much for viewing this portion of the demo. And next up is the voice masquerading portion. Thank you.
My name is Alan Severino, and for the next part of this demo, I will be showing the voice squatting and voice masquerading algorithms in our system. So to start off with, I am going to be using a sample command, and I will show and explain what is going on in the algorithm as we get an output, and then I will show one more sample command, and that'll be the demo. So what you're looking at right now on my screen is part of my code for the squatting and masquerading. When you run the code at the bottom here in the terminal, it will say Alexa on standby, enter command. So for a command, I'm gonna type, our first command will be, hey Alexa, show me some bare facts, please. Enter. Okay, so the reason I am typing in a command is because I don't have a voice to text like translator or recognition at the moment. So I'm just going to be typing in the raw command straight to text and then showing you what happens. So as of right now, the code is running. Since there's a long list of homonyms, it takes a while to traverse through that list. And the more homonyms we got to search for, the longer that may take. Um, so what's going on right now is masquerading and squatting. So what happens in the masquerading algorithm is it will strip off any extra utterances from the original voice command here. So okay, we just got an output here. So this first line that we receive is bare facts. This is the part of the algorithm that handles masquerading. It strips off all extra utterances. So all the extra utterances from the original command were "Hey Alexa, show me some," and "please." The reason we did this was to isolate the specific command that the user wanted. And us being the user, we wanted to know bare facts. So we the masquerading algorithm was able to strip down all extra words except what our intention is, what our the intent of the command is. Once Alexa knows that we're asking for bare facts, all it needs is the stripped um, name to be able to give us the output, give us what we're to like invoke the skill that we are searching for. So this is how masquerading works. Next up is the homonyms. So these next two lists that are shown here are the homonyms. The way the homonyms are found is once masquerading occurs and we strip down all the extra utterances, we're left with just the command we want. And in this case, it's bare facts. So from there, the squatting algorithm will take every individual word from the stripped down command and it will search for utterances. So first, it took the word bear and searched through its list of utterances, and it returned these. We got bean, beat, bew, beer, bard, bear, bark, beer, boar, and boar again, it seems like. In this case, these are words that are homonyms, sound similar, or spelt similar, and the same is done for the word facts. We have facts, axe, phase, faint, packed, wax, and all these utterances are they're turned into their own separate list. And from this point, the algorithm will look through these utterances and it will go look through a list full of malicious skill names. So it will look through this list of skill names and see if any of these utterances from either list are present in that skill name. And if they are, it will alert the user that there may be a risk present. There might be an like another malicious skill under one of these similar names trying to gain access to their machine. So this is how the squatting and masquerading works. Now to show one more example, I will run the code again. And this time I will say, "Hey Alexa, call my aunt." And we will let the code run here. So while this code runs, I'll say that this code should be able to run on the HTML site that Joel just demoed, but due to time and constraints, I was not able to fully incorporate it in a way where I can demo it and show it. So I decided to just do it separately and show it here on the PyCharm terminal. So now that we have our output here, we can see that masquerading, it's stripped down the extra words here, "Hey Alexa" and "my," and left us with "call aunt." So the strip down command we have is "call aunt." Then after that, the squatting part of the algorithm will take "call" and produce this list of homonyms: caller, all, call, hall, carol, and then it will take the word aunt and then make another list of those homonyms: auntie, aunt, aunt, bunt, can't. And yeah, this is just showing that the squatting and masquerading work. Using these algorithms is how we would, one, confirm exactly what it is the user is intending with their command, what it is they want the Alexa to respond with, and at the same time check to make sure there are no malicious skills in the back end of things trying to gain access to the user's device.
Hello, my name is Patrick Denner, and I was part of the team working on the secure smart home protection. My main contribution was to create an Amazon skill that would eventually combine all of the code we wrote into. However, unfortunately, as detailed in the report, we ran into issues and we did not have enough time or resources to fully integrate all of the code into a singular Amazon skill. Therefore, today I'll be providing a demo of how the code would have functioned if we managed to fully integrate the code. So and I will also be showing what we believe are the two main vulnerabilities in the Alexa. So this is the testing environment for Alexa skills provided by Amazon. You can use voice if you have a microphone on your device and say commands such as launch secure smart home protection.
Welcome to Secure Smart Home Protection. Would you like a list of options?
So this will start the skill that we have created, and this is the command that runs when we ask for that skill to launch. So if we say yes, then it will give a list of options and a brief description of what our skill does.
The options for the app are secure transaction and voice squatting. Voice squatting will analyze your voice input in order to prevent malicious apps from running, and secure transaction will provide two-factor authentication when making a purchase.
So, as seen in the description, voice squatting is going to use the homonym detection algorithm mentioned previously in the video to check a voice input and prevent malicious skills from running. And secure transaction will use two-factor authentication and the one-time password algorithm mentioned at the start of the video. So if we can simulate the two skills. If we type in use secure transaction to buy weights, for example.
Enter the one-time password in order to purchase weights.
This would run the secure transaction algorithm and send a one-time password with the one-time password algorithm we went over at the start of the video. And the user would then type in or say the one-time password and would cause another algorithm to run and successfully purchase the item if the one-time passwords match up. I can also demo the voice squatting feature. So for example, if you had an app named Workout, then we can run this command.
Your skill, Workout, will be launched soon.
Which will take the app named Workout and use the homonym detection algorithm mentioned previously in the video to check for any homonyms and potentially malicious skills that can be run, and choose the skill that the user wants to run and launch it through this application. So now I will go over the two main vulnerabilities we noticed while analyzing and writing the code for this skill. So the first vulnerability is with intents. Alexa skills will parse voice data and turn them into intents that contain data and the data will then run the skills. So for example, this is a malicious intent I created called get card info, and if there was a voice masquerading attack which was causing a skill to run silently in the background, then the skill could run until one of these phrases are mentioned, and then for example if the card expires and then the user says a date, the date will be saved and can be sent to a server that the malicious developers are in possession of. So this intent is just an example of many possible intents that could be created to record sensitive data. You can have intents that record birthdays, passwords, addresses, and other personal data. So another vulnerability that we discovered is the ability to customize built-in intents. So voice masquerading attack could be possible using built-in intents such as Amazon.stop intent, which is mainly used to turn off a skill. So this is an example of what the code looks like. So if a user says stop, then Alexa will recognize that as the Amazon stop intent, and will then run this code under the cancel stop intent handler. So a malicious developer could insert code to run here instead of closing the app, and they could do something such as playing a silent noise until a user unknowingly says something in the background while this is running, such as a credit card number or an address, and would then count that as an intent, such as the get card info intent, and save the data of the user. So these are the two main vulnerabilities we've noticed through our analysis and writing of the Alexa code. If we had more time, we may have been able to fully integrate all of our code into an Alexa skill and hopefully create a solution to these problems with our algorithm. Thank you.